In this section, we will be looking at relations and seeing if a relation is a function or not. And so let's take a look at a relationship here. And it talks about how Carlos needs to buy some new pencils from the school supply cabinet. Carlos asks his classmates if they know how much a pencil costs. Well, Angela says that she bought 2 for 50 cents. Paige bought 3 for 75 cents, and Ed bought 4 for $1. And then he seems to think, well, that's kind of like a function. I don't know how much one costs, but you are telling me how much some cost, and so that's the input, the number of pencils. And then that number of pencil gets formed or transformed in this rule into the output, which is a cost of the pencil. And so let's see what we've got. We know that it was Angela. She bought 2 pencils, and 2 pencils. We don't know how that happened, but that changed to 50 cents. So we know that, but we are not sure exactly how that happened. And then from 3 pencils, it goes into this rule, and that gives us 75 cents. And then after that, we had 4 pencils, and 4 pencils ended up costing $1. And so from there, what he thinks of is, well, if that's the case, if I want to know how much X pencils cost, how could I figure that out? X pencils would be like any number, like 2, 3, 4, 5, or 6, all the way up to 12, or even more than that. So what's happening here? Well, if we look at it, if 2 pencils cost 50 cents, and 1 more pencil costs 75 cents, that tells me that the difference between these is just 1 pencil. And the difference between these two numbers, if I did 0.75 minus 0.5, or 75 cents minus 50 cents, that's only 25 cents. So what that tells me, and then just looking at it again, seeing if it makes sense, see here the difference between the number of pencils that, let's see, it was Paige bought 3 pencils, Ed bought 4, and the difference between these two is only 1. So I looked at 4 minus 3 is only 1 pencil. So 1 pencil, and if I look at the difference between these two right here, it's $1 minus 75 cents. If I subtract those two amounts, that gives me 25 cents. So it looks as though 25 cents is the cost of 1 pencil. So the rule would be this. If I took the cost of 1 pencil, 25 cents, and I multiplied it by X, X represents the number of pencils. Number of pencils is what it says up here. That would give me the rule. And so that's what we end up having. So then they say, well, if that's the case, how much would 12 pencils cost? Well, I'd have to take that cost of 1 pencil, 25 cents, and multiply that by 12. And so when I think of quarters, again, I think of 4 quarters making $1. And so if that's the case, if 4 quarters make $1, then another set of 4 quarters make $2, and another set of 4 quarters make $3. And that would be 12 quarters altogether, so that would be $3 that we'd end up having those 12 quarters representing, or 12 pencils representing. So let's take a look at the next set of directions. And so that's what a relationship is. It's relating these pencils to dollars. How do they go from a number of pencils to $1? And that is the relationship. And so what we're going to take a look at next is something called a function. So there's relationships, and then there's functions. And functions can be a relationship, but a relationship is not necessarily a function. So let's talk about what a function is. A function is a relationship when each input has exactly 1 output. And so it's a special type of relationship. And so in this case, these inputs, 15 has to have only 1 output. And in this case, it's 20. So this is okay. So it's basically going from 15 to 20. So 60 only has 1 output of 90, 30 has 1 output of 40, and negative 60 has, well, the same output as 15, but it's still okay, because as long as it has one output, it's okay. So this is a function. We'll say, maybe I'll just say it's a function, and the reason it's a function is each input has only 1 output. So taking a look at the next one, it doesn't matter that, remember how 15 could have 20 and negative 60 could have 20. That's okay. As long as 15 is always 20, negative 60 is always 20, that's okay. And that's what we see here. As long as 14 is always 2, 13 is always 2, 18 is always 2, 19 is always 2. This is a function. So we'll say it is a function. And the reason is each input has exactly one output. So as long as each input has exactly one output, you're okay. Well, here's an instance where this is not a function. Let's see why. You see, 4 is 5. 4 goes with 5. So when I input 4, I get 5. When I input 5, I get 2. When I input 6, I get 8. But then I input 4 again, I get a different number. Notice how here we have an input of 4, and I got 5. I should always get 5 when I have this input, from the input to the output. But here, I input 4, and I got a different output. I got 3. So we would say this relation is not a function because each input, or because the input 4 has 2 outputs. So it's all about the inputs having the same or exactly one output. And if an input has more than one, then it's not a function. So again, the input, and if you were looking at an ordered pair, here this would look like this. This would be 4, 5, where the input is always the x value, the output is the y value. And so I could relate these as a series of ordered pairs like this. And so whenever you're talking about inputs and outputs, the first number is going to be our input, the second number is going to end up being our output. So now we're going to take this idea of a function and we're going to graph it. And so I've got a couple examples here, and this is our rule here, and these x values are our inputs, and we're just going to plug them in. So I'm going to take negative 3, and it's being multiplied by x, negative 2, and then I'm adding the 3 afterwards. So negative 2 times negative 3 makes 6, plus 3 gives me 9. So that point is negative 2, 9. And this next one, the same sort of thing. Negative 3 times negative 1 plus 3. So I've got to multiply first. I get positive 3. And then I add the 3 and I get 6. So you notice a function is when I plug in a number and I always get the same number no matter what. And that's what I get with those two first values. See, every single time I'm going to plug in negative 2, I always get 9. Every single time I plug in negative 1, I always get 6. And same thing with all the others. So if I plug in a 0, I multiply it by negative 3, I get 0. 0 plus 3, that gives me 3. So I have 0, 3. And then when I plug in 1, I multiply 1 times negative 3 there, and then add the 3, and I end up with 0. So 1, 0. And the last one there, I have negative 3 times by 2, and then I add the 3. So I get negative 6 plus 3 gives me negative 3. So 2, negative 3. So those are the points that I am asked to graph, so I just use the coordinate plane. I'm starting from the origin, and I'm going over 2 spaces and up 9. Now, I run out of space, so I'm going to go to the next one. Over 1 to the left, up 6. Puts me right there. And then over 0 and up 3 puts me right here. And then I go over 1 and up 0. Go right here. And then over 2 to the right and down 3 spaces. Puts me right there. And then I can go ahead and draw the line between these points. Put some arrows at the ends showing that the line goes on forever. And I got another example here of this rule is x plus 4. And my inputs are along this left-hand side with the x values. My outputs are the y's. The ordered pair are the solutions that I get once I go ahead and plug the numbers in. So I have negative 2 plus 4, and that gives me 2, so I got negative 2 comma 2. And the next one's negative 1. I'm going to plug that in, and I'm going to add 4. That gives me 3, so I got negative 1 comma 3. 0 plus 4 gives me 4, so I have 0 comma 4. And I plug in 1, and I add 4, and that gives me 5, and so I have 1 comma 5. And the last one is 2. Plugging that in, I add 2 plus 4 gives me 6, so 2 comma 6. So every single time you plug in one of these values, these x values, you always get the same number. Like if I plug in negative 2, I always get 2. When I plug in negative 1, I always get 3, and so on. So then when I graph these, I end up with a line again. Negative 2 to the left, 2 to the left, and then 2 up. Puts me right there. 1 space to the left, 3 spaces up. Puts me here. 0 spaces, and then 4 spaces up. Puts me there. And then 1 space to the right, 5 spaces up. And then 2 spaces to the right, 6 spaces up. And so from that point, I can draw the line between these points. And some arrows at the end showing that the line goes on forever. So those are the types of problems you're going to see on tonight's homework. Good luck.